Thank you. All right, guys, I guess we're rolling here. I gotta make a video because I haven't taught this lesson before, so you guys will forever be immortalized in the Mr. Jenkins video collection here. Isn't that exciting? Um, okay, so yeah, starting into chapter 1 here officially. So I think I mentioned Friday that Monday today would look a little more normal. Did you not get one? I don't remember what you're talking about. Okay, yeah, probably one of those. Yeah. Um, okay, so anyways, yeah, got kind of getting into it here with chapter 1, which is just some kind of algebra basics. We'll cover 4 or 5 lessons, so it'll come and go pretty quick. Usually, I'll give a quiz at the end, so just kind of stay tuned on that. I'm calling this one 1.0 because I already have a 1.1, so I think that's already done for you in your paper. But today we're going to talk about algebraic properties. All right, so basically we'll go through and fill out what these properties mean together, and then you'll try to apply it or use your notes to answer a worksheet. So this lesson is a little bit different than what a normal lesson would look like. For me, because normally we do a set of notes and then you'd get an Alex assignment, right? So this is a worksheet. There just are no real good questions on Alex. With all that said, let's go ahead and get going. Our learning target is I can identify algebraic properties. All right, so we're just going to go through a lot of these properties and kind of use these going forward. All right, so first property we're going to highlight is the commutative property. Notice that this is true for addition and multiplication. But basically, the commutative property says the order of the values does not matter, right? So I'll show you a couple simple problems to kind of show what we're talking about. Basically, that means that 1 plus 2 is equal to 2 plus 1. Do we agree that that's true? Everybody agree that's true? Yeah, because it's 3 on either side, right? So works for multiplication, works for addition, works for multiplication. So we can also say 1 times 2 is equal to 2 times 1. This seems obvious, but I'm giving you simple examples. It does not work for multiplication. It does not work for subtraction or division. Okay, so I think if I try to do 1 minus 2, that'd be negative 1. 2 minus 1 is positive 1. So it doesn't work with subtraction or division. Okay. Then we have the associative property. So associative property says grouping of values does not matter. Grouping. Anybody know what math symbols we use to show grouping? How do we group numbers together? Yes, sir. Yeah. Brackets or what else? Parentheses. That's right. I know you were showing them. That's right. So typically parentheses could be brackets as well. But this is true that it doesn't matter how we group in addition or multiplication. So if we tried like something like 1 plus 2 plus 3, that would be the same as if I did 1 plus and then group 2 plus 3. We think about our order of operations there. On the left side, we'd have, 1 plus 2 is 3, and then 3 plus 3 is 6. On the right side, we'd have 1 plus 5, which is also 6. So it doesn't change the value when we change the grouping. Okay. Also true with multiplication. So I'm just going to change the symbols here to multiplication. So 1 times 2 times 3, that would be 6. And then 1 times 2 times 3 would be 1 times 6, which is also 6. All right. So these are properties. The first 2 are properties that are true with addition and multiplication, but not subtraction and division. Okay. it's important that you know that addition and multiplication are associated, right? Multiplication is repeated addition. Hey, will you put your Chromebook up for now? So we finish this. Thank you, thank you, thank you, thank you. All right, then the identity property. So what can we add to something that it preserves its identity, aka means not change it, and what can we multiply something, okay? So basically, if we add 0 to something, it doesn't change it. So we're just going to say x plus 0 equals x. And if we multiply something by 1, that also doesn't change it, right? So I'm going to say x times 1 equals x. So the identity property is either when you add 0 or multiply by 1, okay? So again, take any number. Let's just say 1. If we take 1 and add 0, we get 1. If we take 1 and multiply by 1, we get 1. All right, let's do a couple more, then we'll take a little break. Okay, so the inverse property. Inverse property, there's an inverse property for addition and multiplication. Okay, so we want, when we're adding, think about solving an equation here, right? Additive inverses add up to 0. Multiplicative inverses multiply to 1. So this is a little tricky. I'll show you what I mean. So to fill in the blank, it says using blank to cancel a value. Let's just fill in the word inverses there. On our key statement of our DMR, we talk about, or I talk about, using inverse operations to isolate the variable. Okay, this is inverses. All right, so an additive inverse would be something like a number and its opposite, right? So if we said 2 plus -2, those numbers add up to 0. All right, and then if I took 2 and if I want to multiply by its multiplicative inverse, that would be 1 over 2. So 2 times 1 over 2 is equal to 1. You'll learn this as we go throughout the year, but times 1 over 2 is the same thing as divided by 2. Okay, times 1 over 4 is the same thing as divided by 4. All right, so we have 1, 2, 3, 4. Let's do one more and we'll take a break. All right, the property of 0 basically says this. Multiplying by 0 always equals what? 0. Okay, so just to spice it up a little bit, I have my notes, but I'll have you guys just give me a number. How about, trying to learn your old names, I'm sorry. Excuse me here. How about Macy? Give me a number, any number. 5, right? So if we take 5 times 0, we get 0. Macy could have given me any number. If I multiply it by 0, we get 0. A lot of these will seem really obvious, and that's okay. All right, so take about 3 minutes to just, I would suggest you get up and move around for a minute. If you've ever been to church, sometimes the preacher says get up and go say hi to people. This is like that part of class. So just a chance to just kind of relax for a minute, and then when the buzzer goes off, we're right back to it. Okay. If you can hold it, I'd rather you wait till 6th period, because the problem is if they shut all the bathrooms down during 5th period, because they really want you to go in the spine. If you can't hold it, then you'll have to go to the health office. Yeah, that's fine. You really need to go there. All right, take one of those and go to the health office. Take one of those lanyards and go to the health office. Do you know where that is? It's in the main office. Yeah. And then in the future, just try to do that during lunch, okay? All right, guys, you're wrapping up those conversations. Our timer will go off in about 10 seconds or so. Let's just finish the notes. Well, 5th period, you know they have them all shut down. So.
Oh, yeah, because it's lunch, it's so retarded.
I know, you got to get used to it. It's what it is. Wonder if that made the video. That'll be a good addition to the video there. All right, let's go ahead and finish up here. Okay, so eyes on the board here, and we'll get it done. Distributive property should be a familiar one to you, hopefully. The distributive property says multiplying a value to an expression inside parentheses. So usually we'll have something like a monomial, which is one term, times a binomial, which is two terms. So something like this. So we have 2 times, x plus 3 or something. That's distributive property. All right, so basically the way you do that is you take 2 times x, which we call 2x, plus 2 times 3, which is 6. That's how the distributive property looks. Does that look familiar to you guys? Yes, hopefully. All right. The 3 on the back are like, 2 of the 3 are like super obvious. But sometimes we can use super obvious things to like prove more complex things. That's why they're properties. Okay. Reflexive property, again, the most obvious thing ever, just says any real number. Somebody just used the number sign there. Any real number is equal to itself. The most obvious thing you've probably written down all day, right? Okay, so we could say, something like 3 equals 3. Who knew math could be so easy, right? And then the symmetric property. Sometimes this one, if you don't have a good grasp of this one, it can cause you some trouble when you're solving equations. But basically, this says we can interchange sides of an equation. We can interchange sides of an equation. I'll give you a second to get caught up there. We can interchange sides of an equation, and it preserves the truth value of the equation. Right, so a lot of equations will end up with something like, you know, x equals 20 or something, right? So what we can say, if x equals 20, then it's also true that 20 equals x. If x equals 20, sorry, that is not true what I wrote up there. I meant to write 20 equals x. If 20 equals x, sorry, if x equals 20, then 20 equals x. Wow, screwed that one all up.
So we just flip-flop.
You just flip-flop it, right? So sometimes, you know, the reason this can be helpful is because sometimes, you know, they put the variable on the right side there, and people, that throws people off. But basically, if you end up with 20 over here and x over there, that's the same as if x equals 20, okay? All right, and then the transitive property. You may or may not hear this one cited in a non-math example. Sometimes people will. But basically it says this. This is like a logic kind of thing. If A equals B and B equals C, then, does anybody know the rest of it? If you've never heard it, then I don't think it would be obvious, but then it's true also that A equals C. So basically, like B is like the bridge from A to C. I'll give you an example. Or maybe we'll come up with one together. All right, so I'm going to give you a simple equation that's obviously true. So let's say if 1 plus 2 equals 3, and 3 is also equal to, let's see if anybody can help me come up with another way to make 3. Let's use subtraction. What's a subtraction expression that's equal to 3? 6 minus 3. So everybody agrees 6 minus 3 is 3. So 3 is equal to 6 minus 3. Okay, if all that's true, which it is, okay, 1 plus 2 is 3, 6 minus 3 is 3. Now we can also say then 1 plus 2 must be equal to 6 minus 3. Which again, it's kind of obvious with these numbers, but these things are used in like proofs and stuff. So, all right, so that'll conclude your notes. Usually you would have an Alex to go along with these. Today you have a worksheet, okay? So I would keep these out to use on your worksheet. I know a lot of you are packing them up. I would hold off on that.